Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3510. Minimum pair removal to sort array 2. So in this problem you are given an array nums and you can perform the following operation any number of times. We have to select the adjacent pair with the minimum sum in nums. And if multiple such pairs exist, then we have to choose the leftmost one. And then we have to replace the pair with their sum. And we have to return the minimum number of operations needed to make the array non-decreasing. Simply means in increasing order. This is what we need in increasing order. An array is said to be non-decreasing if each element is greater than or equal to its previous element if it exists. So this is your non-decreasing array 2, 3, 3, 4, 5, 6. So see here the previous element, it is less than or equal to the next. If this is not the case, then it is not non-decreasing. So if each element is greater than or equal to its previous element, then that array is said to be non-decreasing. Clear? Now see this example number 1. So here this is one pair 5 and 2, sum is 7. Then this is one adjacent pair, sum is 5. Then this is one adjacent pair, the sum is 4. So among them, what we need to select? We have to select the adjacent pair with the minimum sum in nums. So this one is having minimum sum. So I'm going to select this. So my new nums is going to be like this: 5, 2, and here 3 plus 1 I will get 4. Select the adjacent pair with minimum sum in nums, and if multiple such pairs exist, choose the leftmost one and replace the pair with their sum. This is what I did here. Now next time, here again check. 5 is greater than 2. So no, it is not a good array as of now, because what we need array to be non-decreasing. But here see, this 5 is greater than 2. So again, let's do this. 5, 2, 7, 2, 4 is 6. So among them, we have to choose minimum one. So this one I'm going to choose. So I'm going to remove these two and I will get 5, 6. Now here if you see, 5 is less than 6. So that simply means now this array is non-decreasing. Clear? Now how many operations we did? So this is one operation we did here, and this is second operation we did. So total 2 operations we did, and finally we get this, where our array is non-decreasing. So see this explanation. The pair 3, 1 has the minimum sum of 4. After replacement, nums is going to be like this: 5, 2, 4. The pair 2, 4 has the minimum sum of 6. After replacement, nums is equal to 5, 6. The array nums become non-decreasing in 2 operations. So this array 5, 6 becomes non-decreasing in 2 operations. Clear? All right. Now here, yesterday we have solved same problem like part 1 of this one, same problem statement and same examples here. But in this problem, the constant size was very small in the part 1. So we were able to pass our solution in off and square. But in today's problem, if you see, the nums dot length value is from 1 to 10 to the power 5. So we can pass our solution in off, and we can pass the solution in off and log n, but we can't pass the solution in off and square, because if I did this, so I will get off 10 to the power 5 square, I will get 10 to the power 10. So this will definitely give me time limit exceed error issue. So definitely I can't solve this problem in off and square. So now what we need to do? First, see this here what we are doing. So here we are checking, we are continuously checking. First we are checking if our array is non decreasing. This is what we are checking. So if it is non-decreasing, we are stopping, right? But if our array is not non-decreasing, if our array is not non-decreasing, then in that case, what you need to do, you have to find the sum of all the adjacent pairs and select the minimum sum pair, and it should be leftmost. This is what you need to check. So here, first for checking, you are checking complete array, right? So here you are running of n time. Then you have to find the sum of all the adjacent pairs. So let's say there are some elements a, b, c, d, e. So here you are checking a plus b. Let's say it is equal to some, it will give some value. Then you are going to compare this sum with this sum. Then you are going to compare the sum of c plus d with the previous sums, and you have to just select the minimum one. So here again, you are going to run for of n times. Clear? Okay, this is done. Now after that, let's say you select. Now after that, you have to delete that pair where we are getting minimum sum, and you have to insert the sum now. So let's say you have array like this a, b, c, d, e. Let's say this is giving you the minimum sum. So next time a, b, let's say here you fit x and this. So here, see, you are deleting one element, and c plus d combo, let's say you are writing here in this x position. So again, all the elements will be shifted. So you have to insert sum, and then you have to adjust the indexing as well. So again, you are doing of n. Clear? So all these things you have to somehow optimize so that you don't solve this problem in of n square. So here finding the this of n, then this will take of n, and here also you are checking of n times. First you have to make sure that your array is not non-decreasing, then you have to do all this stuff. So this is what we were doing in part 1, all this stuff. Now we have to somehow optimize our code. So how we are going to do this? That's what we have to see now. So let's take this same example. Let's say 5231. Let's say you have 5231, 5231, and let's say here you have some other number. Let's say 20, 30, or let's not make it much big. Let's take it until here. Now here, this is done. So first thing I told you that let's say these are index: 0 index, 1 index, 2 index, 3 index, 4 index. So first you need to store the sum of the adjacent pairs. So 5 plus 2 is 7, and then here 2 plus 3 is 5, then 3 plus 1 is 4, then 1 plus 20 is 21. These are the sums. And let's do one thing. This is one sum you are storing. So let's say this 7 is at 0 index. So here I am writing the index, and here I am writing the sum. So 0 means starting at 0 and the next element. So 0 and 1 are adjacent. So here I am writing 5 and starting from 1. So starting from 1 means 1 and 2. Combination of 1 and 2 index, I will get 5. Same way 4 is nothing but sum is 4 starting at 2 means 2 and 3 index values. If I do the sum, I will get 4. So here I'm writing 2 at this particular position. Then here I will write 21, and I will say start at 3. So here these are the pairs that I'm writing. Pairs. So in the pairs I have sum and I have index. Now this is what we are doing here. We are checking if our array is non-decreasing, and then after that we are checking find the sum of all the adjacent pairs. This is what I am checking, and then we are selecting the minimum sum pair leftmost. These two things we need to take care. So now what I can do here, this is my pair. Let's put this pair in some data structure, in which I will sort the values based on the sum, whatever the sum, and if the sum is same, then I want the values to be sorted based on the index. These are the two requirements. We need leftmost value if sum pair is same. Otherwise, we need the minimum sum value to come in the front. This is what I need. So definitely two things may come to your mind. One is min heap, you can say, because in min heap, if you pass all the pair elements and you somehow write the logic so that minimum sum always come to the top. So all this stuff, right? This is what you can try, or you can also try to use TreeSet. TreeSet you can try to use. So let's use the TreeSet here. Sorting will automatically be taken care, right? I will write one custom logic as well in the TreeSet. So what I will do here, let's say I have two pairs that I need to compare, A and B, let's say. So I will write code like this. If my A dot sum is not equal to B dot sum, let's say I'm comparing this and this. So in this case, my A dot sum is not equal to B dot sum. Then I'm just going to compare the sum, and whatever the sum is minimum, I will write first. Like 4, this pair is going to come first. If in just I'm comparing these two. But let's say here also we have 5. So in this case, if sum is same, then I'm going to compare these two pairs based on the indexing. So whatever minimum index, like here it is 1, so this is going to come first. So this is my first thing that I am planning to do here. So now after sorting, how many pairs are going to look like? So they are going to look like this: 4 at 2, 5 at 1, 7 at 0 index, and 21 at 3 index. So this is after sorting. This is what I need. That's what I'm saying. Okay, clear this part? Now this is done. This is done. Now here, from here, one thing is clear, that you have to delete this first, because this is having minimum sum, and this pair is starting from index 2. That simply means it is combination of index 2 plus the value at index 3, combo of these two. So here, that simply means I'm saying let's delete this. Let's delete this. This is what I'm saying here. Now if I delete this, and in this place if I write 4, I have to update these two values with the sum, and I have to write this at value, this 4 value at 2 index. This value 4, I have to write it at index 2. This is what I need to do, right? 5 comma 2, then 4 comma 20. This is what I need to update. Right? Okay, but still, if I'm doing this, and here there are so many elements, let's say it's very big, so I have to shift all the elements again and again. So again, the removal of one value from here, so and inserting of this, let's say insert is easy. Let's say I inserted one element, then again I have to shift all the elements, so again the time compressed is going to be of n. I am not able to optimize it yet. So now I need to see how I can further optimize it. So let's do one thing. Let's do one thing. Here, let's not delete the element. Let's not delete this. Let's not change anything from here, this array. Let's not change anything from this array. So now what I can do here then in that case? So do one thing here. See, somehow this one is going to if you see this, if I just, let's say I just give the indexing here 0 1 2 3. So now here this one index, it is pointing to this complete, and then this complete is going to point to this, right? Okay, so now here can I think of a linked list here? Right here, if I have elements like this a b c d, let's say, and let's say a is pointing to b, b is pointing to c, c is pointing to d. Now, and let's say d is pointing to e. Now let's say I have deleted these two, c plus d, and I am inserting x here. So now I have to point this b to x, then I have to point this x to e, like this, like this. I can try. So now in this case, it will not take off n for me, right? So now this is one thing I can do. You have values like this 5 comma 2, then you have 3 comma 1, then you have 20. So this is your 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4 index. So now here what I will do, I will create two arrays, let's say next array, and one array name is priv. So in this next and priv array of same size, I will create, and in this what I will fill, so whatever the next value for this index 0, for this 0 index, what is the next value? So this is connected to this one index, right? So I'm going to write 1 here. This is connected to 2, so I'm going to write 2 here. This index is connected to this 3, so I'm write 3 here. This index is connected to this value, so I will write 4 here. For this one I will simply write 5. So I am saying that my 0 index is connected with 1, my 1 index is connected with 2, my 2 index is connected with 3, my 3 index is connected with 4, my 4 index is connected with 5 as of now. Let's say okay. Same way for priv. So this is again 0 1 2 3 4. So 4 priv is 4 priv is 3, 3 priv is 2, 2 priv is 1, 1 priv is 0, and here I will write -1. This is easy, right? This is easy. Just I am adding the linking indexes as of now for this array. I haven't deleted anything as of now. Clear this part? And these are the pairs that I've added in my set. So let's say 4 comma 2, I'm writing the same thing. Okay, it's written over here, you can follow from here. Okay, these are the pairs as of now. Now among these pairs, now if I plan to delete this, if I plan to delete this, now that simply means starting from 2 and 2 plus 3 combo. That simply means this is what I am planning to remove. This is what I plan to remove. So for this, let's say I extract the information from this. So for this, let's say this is my left side value. Let's say this is my right side value. These two things I'm extracting. For 2 means 2 comma 3. So 2 index simply say, let's say left index. 3, let's say right index. Clear this part? Okay. Now after this, see here, this 3 plus 1 4 and 2, it is getting impacted. I am removing this green part. So because this I have to operate, removing this part. But about this 2 3, because 3 and 1 is going, but we are taking adjacent, right? This, then these two, then next two. We are always like, if we have elements like a b c d, so these two are adjacent, these two are adjacent, these two are adjacent, these two are adjacent. So now if I'm planning to remove this, so what about this part and what about this part? These two things also will be impacted, right? Because of removal of this one. Because I'm removing this green part, this 2 plus 3, that simply means 5 starting at 1. This is getting impacted. Same way here, 20 plus 1, 21 at starting from 3. This is also getting impacted. So I have to take care of these two things as well. These two things as well I have to take care. So now what I'm going to do here, left, your left index is at 2, your right means the after the left, what's the value. So I can simply, can I do here, write it like this, next of left. So next of left value is 2, so this 3. So definitely I'm talking about 3 here as of now. I haven't written anything, right? And this 2 value is nothing but the pair, this pair I have removed, the first pair I have removed. So p dot index, so this is nothing but index value. Now I know that this is getting impacted, this is my left, so left neighbor is getting impacted, and the right neighbor is also getting impacted. So let's write here left neighbor and right neighbor as value as well. Left neighbor index and the right neighbor index. This is what I'm saying. So here let's say neighbor. So here I can say left neighbor is nothing but the left is at 2. So prib of the left. This is what I can say, prib of left. I will get the prib of left means I will I'm here. So at prib of left. So my left is 2. So left is 2. So prib of left. So here I'm writing 1. So 1 is the value, right? So previous index. So left neighbor is at 1 index. Same way right neighbor I can say your right, next of right, I can say next of right. So this is how I will get that. So that is nothing but next of right. So next of right is nothing but 4. So I will get 4 here. Clear this part? This simple part clear? Now all these things I know. Okay. Now before proceeding further, here, tell me one thing here. Let's say your array is like this. You need array to be non decreasing. This is what is the requirement, non decreasing. That simply means you need it in increasing order. Right now let's say all the elements are in decreasing order, 9, then 7, then 4, then let's say 2, let's say then after that we have 1. So here in this, the what is the n value? 1 2 3 4 5 values are there. Now how many number of bad pairs, how many number of bad pairs are there? So bad pairs, I will say the definition of bad pairs is if this array, if array of I value is greater than array of I plus 1. So I will say that these are the bad pairs. So here 9 is greater than 7. So this is one bad pair. Now this is another bad pair. This is another bad pair. And this is another bad pair. So total bad pairs, if you see here, is equal to 4. That is nothing but n minus 1. So this is the worst case scenario. This is the worst case scenario in which we are getting n minus 1 number of bad pairs. N is 5 and all the pairs are bad pairs. Now I have to remove these bad pairs one by one. And in the end, if let's suppose your bad pairs is equal to 0, let's say, what does this mean? If your bad pairs is equal to 0, that simply means you have the array which is non-decreasing. There are no bad pairs. So this is what we need to do, right? So initially I will count the total number of bad pairs in my array, and after that I somehow, let's say I calculate total bad pairs to be 100 initially, and after that I did some adjacent pairing, I remove the elements, I insert the new element, and somehow my bad pairs become 0. So in that case I have to stop. In that case I have to stop. That simply means my array becomes non-decreasing, and that simply means my array is in increasing order. This is the thing we need, right? Okay, now just keep this thing in mind. Now here in this same example, tell me how many number of bad pairs are there. How many number of bad pairs are there? Okay, so here this is one bad pair. 5 is greater than 2. 2 is greater than 3. No, this is not a bad pair. 3 is greater than 1. Yes, it is bad pair. 1 is greater than 20. No, this is not bad pair. So total bad pairs are 2, which are 5 is greater than 2 and 3 is greater than 1. I don't see any other bad pair. So these two bad pairs. So I have to somehow make these bad pairs equal to 0. Now here I am planning to remove this 4 and 2. So that's means I'm talking about this pair. Now here A and B, let's say I plan to remove. Let's say the value comes out to be X. If I just do the summation of this is what I need to put. So the left child is also getting impacted from these two. So let's say this is my left child. Why I'm saying left child? Let's say left neighbor is also getting impacted, because there is one pair of left neighbor and this A, right? And my right neighbor is also impacted because there is one pair of this. Clear? But now let's say I'm not taking this complete as of now, because you know that here 3 and 1 I'm planning to remove. So here first thing definitely I have to check 3 1 I'm planning to remove. Let's say 3 and 1 is nothing but A comma B. So if tell me if your A is less than B, A is less than equal to B, then that means it is not a bad pair. It is not a bad pair. It is not a bad pair which I am removing right now. But if A is greater than B, that simply means it is a bad pair. It is a bad pair. So here in this case, if I am removing this, definitely that means I am removing one bad pair. So I have to decrement the bad pair. Clear? This part what I'm saying here. But there is few twists I need to take care. Okay, so let's analyze that. So first thing, just simply this is your first step. Let's say remove, if you are removing bad pair or not. So if you are removing bad pair, then just do bad pair minus minus, bad pair minus minus in this case, because you are removing this now. Okay, but now I have to see the impact here as well, because there is a pairing of left neighbor and A, right? So let's not see this complete diagram. Let's see this diagram only. Left neighbor, and let's say you have A comma B here, which you are going to replace with X. Okay, now here previously, let's say if your left neighbor value is less than equal to A, then it is not a bad pair. Then it is not a bad pair. But if your left neighbor, let's say, is greater than A, that simply means it is a bad pair. It is a bad pair. This is, I'm talking about this part. Okay, now what happens? Now this A is getting removed, right? Because in this complete place I'm going to put X. So next time this X is going to the neighbor of this left neighbor. So we have left neighbor, and here we have A plus B combo. So now there are two things that's going to happen here. Maybe my left neighbor is again going to be less than equal to this, or my left neighbor is going to be greater than a plus b. These two things, these are the possible scenarios that can happen here, right? Previously this was the case, but now these two things I need to check. Okay, now here tell me one thing, just notice carefully here. So if the your left neighbor value, okay, if your left neighbor value is greater than a, and your now new left neighbor value is less than equal to this a plus b, so it was a bad pair previously, but now it is a good pair. Now it is a good pair. So in this case, in this green color thing, you have to do bad pairs minus minus. Clear? So previously it was a bad pair, but now if you do the a plus b, it becomes a good pair. So definitely you have to remove a bad pair. So here you did bad pairs minus minus. Same way, let's say if previously your left neighbor is less than equal to a, it is not a bad pair, but now what happens, this left neighbor becomes greater than a plus b, then it was not a bad pair, but now it becomes a bad pair. So in this case, this blue color thing, whatever I have written, so in this case you have to write bad pairs plus plus, right? Clear this part? Same thing you have to do for this right neighbor as well, this right neighbor. So again, here a and b general, and let's say here your right neighbor. So two scenarios, maybe b is greater than right neighbor, then that means bad pair, or if b is less than equal to right neighbor, that means good pair. Now what is going to happen, you are going to combine this a plus b, then maybe it becomes greater than right neighbor, or if you combine this a plus b, then maybe they are less than equal to right neighbor, these two things. So if this thing happens, then that means it is going to become bad pair. If this thing happens, that simply means it's a good pair. So now again we have to fix the right side. So again, if your right neighbor, is greater than equal to this, that simply means it was a good pair previously, and now what happens, your right neighbor, it becomes smaller than this a plus b, it becomes bad pair. So in this case you have to do bad pairs plus plus. And same way, if it was a bad pair previously and now it becomes good pair, so in this case you have to do bad pairs minus minus. These two things you need to take care, right? Okay, now let's again come back to our problem, right? So now here what you are doing, so you have to update this to 4. Let me use some other pen. You have to update this value to 4. Okay, now here definitely we have to update this next and prev now. Okay, so when you are going to remove these two, so then you are writing 4, you are going to write this 4 at this 2 index, and this I'm not going to change. Okay, so your new array is going to look like this 5 2, and here I'm writing 4, and here I'm writing 1, here I'm writing 20. This is what I have updated, but somehow I will make it meaningless. Instead of removing it, I will make this value meaningless. Okay, so what I'm going to do here, so now this 20 is at 4 index, so this 4 index, instead of pointing it to 3, it is going to point to 2 now. So I am saying the preb of 4, I am going to make it 2 here. Preb of 4, I am going to make it 2. So here you have 0, 1, 2, 3, 4. So preb of 4, I am making it to this now directly. Clear? This part. Same way here we have 4. So next of this, I will make it to this. So next of 2, here I am operating 4, right? So next of 2, I am updating it to 4 directly. This is what I need to do here. Clear? This part. So this is my idea to do this. So now 0 is pointing to 1. 0 after 0 we have 1. After 1 we have 2. After 2 we have directly 4. And at 2 you know that we have already stored 4. Same way if you see the preb now. So 4 preb is 2. And at 2 we have now 3. Okay. 4 the new value, right? Same way now after that I check this. So at 2 my previous 1, then at 1 previous 0, like this. I have made the changes. Clear this part? Now same way from this is your set. This is your set. From this set also you need to remove, update the pairs, right? So definitely I have to remove this one because of this, and remove this one because of this, right? And now I have to add the new pairs. I have to add the new pairs. So what are going to be those two new pairs? So again, left and left neighbor I will add. Left and left neighbor I will add. Okay. So left neighbor plus left, I'm going to but I'm saying I'm planning to add the left and the left neighbor. So that my left is this. Let me use some other pen now. Here, this color, let's see. So this is my left, and this is my left neighbor. This is what I'm going to do addition, and I'm going to store the value at 1. So here 2 plus 4 is 6. 6 I'm going to add at 1. This is what I'm going to add now, 6 comma 1, and that is correct. These two, 6 comma 1. Same way uh, and this here this 4 is nothing but this 4 is a combination of left plus right. So you can say left plus right, and this all this I am combining, all this I'm combining, this complete I'm combining, and I'm writing it at 1. Okay, this is what I'm doing here. Same way in this side you are going to add all this. That is going to become now 24 and 24. And for 24, where you are going to store starting of this 24. So starting of this 24 is going to be at the left, which is 2. So that's these two things you have to add again to the set. And again, whatever comes first, that will be minimum, that will come to the front. And again you have to do it, and side by side you have to increment the bad pairs or decrement the bad pairs. And in one operation we are removing one pair and adding the sum. So that is one operation. So side by side I will do the operations plus plus until my bad pairs become 0. So I will side by side do operation plus plus. So these are the things I need to take care. So I hope that you guys are clear now what I'm trying to do here. Okay, then I'm going to write the code. I'm going to write the same story whatever explained here, nothing different from this one. Okay, so don't worry about the code now. Okay, so let's write the code and side by side understand what I'm doing here. Okay, let's write the code. So first thing that you need to do here, just create the pairs. So here I'm going to write static, and in the pairs you already know that you need to store the sum and index. So here let's name it pair, this class. And here inside this, what you need to do, you have to create a two variable, let's say long sum, and the index I have to store. So here I write int index. These two things you need to store. And let's create a constructor here pair, and just pass two values, that is nothing but long sum. And here you have to write int index, and here you have to just simply write this dot sum is equal to the sum value that is what we have, and here this dot index value is going to point to this index. That's it. So this is my pair class that I've created. So here first thing that you can do here after writing this class pair, so just calculate the length of this nums. So nums dot length, and here let's copy this nums to a long array because I have to push the sum right in the nums array. I have to select the adjacent pairs and then I have to add the sum inside the sum. So that value may not fit in the int type. So that's why what I plan to do here, I plan to copy you can say nums to long array. So here I will do long array is equal to new long n, and here I will write for int I is equal to 0, I is less than n, and here I plus plus, here I will just simply say array of I value is equal to the nums of I value. That's it. Now I told you that we have to use TreeSet to always get minimum adjacent sum. So here TreeSet to always get minimum adjacent sum. So here I'm writing TreeSet pair set is equal to new TreeSet, and in this new TreeSet, let's say you have two parameters a comma b. So two pairs, let's say you are trying to compare. Okay, so those are nothing but let's say a comma b. Now what I will do here, for these two I will first check if a dot sum is not equal to b dot sum. So if this is the case, then in that case just simply compare their sum. Long dot compare, and here you will write a comma a dot sum. So from pair A just get the sum, and from pair B just get the sum. And if sum is matching, then just compare their indexing. So here I write integer dot compare, and here a quick question for you. Okay, just try to answer in the comment. What is difference between this int and this integer? This is very important interview question. Okay, try to answer it in comments. So here I'm writing integer dot compare, and here I write a dot index comma b dot index. That's it. This is what I have to do here. Done. This is how my tree set is going to work. Then I have to simulate the linked list. Okay, this particular tree set, you can say simulate it, simulate the this linked list, whatever you want to say. Okay, so here for that purpose you have to create the next and prev. So new int n, and here int prev is equal to new int n. Okay, and here now I have to just fill the values in this. So it is also going to be very simple. Int I is equal to 0, I is less than n, I plus plus, and here next of I value I told you that it is going to be just I plus 1. Same way prev of I value is nothing but the current I value, just subtract 1 from it. Right now, initially this is the case, right? So this is how I'm going to fill everything. So this is done. Then after that, let's count the bad pairs as well. Count bad pairs. So here int bad pairs is equal to 0 initially, and then for int I is equal to 0, I is less than n minus 1. So this is going to be your max number of bad pairs until here. Okay, n minus 1 only. That I have explained, right? So here what you need to do, if array of I value is greater than array of I plus 1, so in that case just do bad pairs plus plus. Clear? And in the set just add the bad pairs. In the set we have to add all the pairs actually. Set new pair, and here array of I plus array of I plus 1, and I told you it is this pair is starting from I. So here I will write I. That's it. This is what we need to do here. So now after that just we have to calculate the operations. So int operations is equal to 0. So right now there is nothing I did in the code, nothing complex, right? And after this also very easy, same story whatever I have explained, I'm going to write same thing line by line. So here I told you while your bad pairs is greater than 0, just do the stuff that I'm going to write inside this. So first extract the pair, the front pair with the minimum sum. So here you write set dot poll first. Okay, now I told you just get to the left is nothing but p comma index. Then I told you get the right, so you are going to just say next of this left, use this next only, right? Because in future we may update the neighbors, right? So we left is always fixed. Okay, in the pairs we are always adding the starting index, but after that what is the index that we are not sure, so always add it like this. And I told you let's calculate the left neighbor as well. Left neighbor is going to be prib of the left, and what is going to be a right neighbor, int right neighbor is equal to next of right, and we have to remove bad pair left comma right. So just check if here array of left value, if it is greater than array of right value. In this case, if array of left value I'm saying, right, here array of left value, if it is greater than array of right, in this case what you need to do, just do bad pairs minus minus, and then we have to fix the left side. So mid side I fixed, now we have to fix the left side, fix left side. So here just check if your left neighbor, okay, this neighbor spelling is correct I hope. If left neighbor is greater than equal to 0, then in that case the old value is nothing but the array at left, whatever the value you have. So this is your old value, and new value is going to be array of left plus array of right. So long new val is equal to array of left plus array of right, these two. And now after this you have to just simply check if array of left neighbor, okay, if array of left neighbor it was greater than the old val. So if this is the case, that simply means it was the bad pair first, but now this time what happens, after that array of left neighbor value, it becomes less than equal to the new value, which is a combination of array of left plus array of right. So that simply means we have to remove the bad pairs. So bad pairs minus minus, and here else if array of left neighbor, previously it was less than equal to old val. So previously it was good pair, I'm saying old val, but this time what happens, array of left neighbor, this time it becomes greater than the new val. So now it is a culprit, new val. So now we have to do bad pair plus plus. So here I will do bad pairs plus plus. That's it. That's what we need to do here. That's it. And here your if condition is over. Now you have to fix the right child. See, so easy. You don't do anything complex yet. And actually there is no complex now, since you already understood the problem. So here, can we do one thing? Can we copy this and we will update side by side? Okay, so if right neighbor, this time if I'm saying if right neighbor is less than n, only then update na. If right neighbor is less than n, otherwise you go out of bound. Okay, if right neighbor is less than n, then old value is right and the new value is array of left plus array of right, and then here you have to check if array of right neighbor, right, if it is greater than equal to old value, and now what happens, array of right neighbor becomes less than new val. So now this time simply means that your bad pairs is going to be incremented, right? Same way, if array of right neighbor, here right neighbor is less than old value, it was less than old value previously, but now the array of right neighbor, it becomes greater than equal to new val. So in this case your bad pairs is going to be decremented. So right neighbor is greater than equal to new val now. Okay, so simply means the previous two values are smaller than. Okay, so that means good. So bad pair minus minus. Okay, so this is done here. So you have fixed this. Now what's left? Nothing. Okay, just we have to update the tree set pairs. So how you are going to update those? So again, if left neighbor, let me copy this neighbor again and again. I have to write if left neighbor is greater than equal to 0, then what you need to do? So here you have to write set, first remove from the set dot remove. Set dot remove is equal to new pair, and here array of left neighbor plus array of left, right, because we have to remove these two now, and this is at which index? Left neighbor index, right? This is what we need to remove here, and same way we have to add this time. So what I will do, simply let's copy this, and this time we have to add now. So here I will write set dot add a new pair, and here array left neighbor plus array of left plus array of right. This is the new values we have to pass, and it will be at left neighbor only. That's it. Now same thing you have to update for the right neighbor. So here you have to write if right neighbor is less than n. If right neighbor is less than n, set dot remove new pair array of right plus right neighbor. So here array of let's copy this, right? So array of right plus here you have to write right neighbor. So you can copy this now. Okay, copy is complete. Right neighbor. So array of right plus array of right neighbor. So here you have to write right at a right. You are going to remove this. Okay. So right and right neighbor is starting from right now. So that is why I'm writing right here. And set dot add new pair. And here I have to write array of left plus array of right plus array of neighbor. So this is what I'm going to update here. Okay, and here we have to write left only. So this is starting from left. That's it. And here do one thing, update this preb of your right neighbor, preb of right neighbor to the left. So these things you need to take care here. And then we have to simply merge. Now only 2-3 lines are pending. Okay, don't worry. So here we have to just merge. So here next of left, I told you it is going to become equal to your right neighbor, and I told you that your array of left this time is going to be the combination of array of left plus array of right, and every time you have to do operations plus plus. That's it. That's it. And in the end here, see this while loop ends, and now if your while paired pairs is becomes less than 0, so in this case just simply return what these operations. Okay, now let's run it and let's see if we need to fix anything. Yes, definitely. So line number 73 only. Okay, no issues, it's just one line then. Okay, let's fix it. Let's run it again. So see, all the test cases have been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity is going to be of n log n. That's it. It's not of n square. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.